Hi there. Today we're going to talk about vertical sextant angles. A vertical sextant angle is the angle that's created between an elevated object and the horizon. And you can use it to determine your distance from that object and thus create a position line indicating where you are. So here we go. So to demonstrate how a sextant works, we'll have a look at this image of the coastline. The sextant works by taking the top of this lighthouse and moving it through a series of mirrors down onto the horizon here, and then measuring the angle that you get as a result of doing that. And so if you look through a sextant, it'll look something like this. You'll see the lighthouse superimposed over the horizon. And then on a scale on the sextant, you'll be able to read off the angle. So that's how we get a vertical sextant angle. So here we have a lighthouse that's sitting on a hill. And we determine that the angle of that lighthouse from the horizon or from the shoreline is 28 degrees. Using calculations or using a lookup table, we can get a line of positions that we possibly could be, known as a position line, and that's this arc around here. Now, I've talked about position lines in a previous video, and I'll link that video down below if you want to have a look at them. Now, I should warn you that this section contains mathematics. You have been warned. So to determine your position, and in this case we're going to use meters, we're going to use meters for the height and meters for the distance, you can do it mathematically quite simply. The distance from the lighthouse is the height divided by the distance equals the tangent of the angle. So in other words, tan of 28 equals 155 divided by d. If you do your mathematics and spin that around, the distance out from this lighthouse is 155, which is the height, divided by the tangent of that angle 28. In this case, it gives you a distance of 291 meters. So distance equals 291, and on your chart you can draw a distance of 291 meters. Now that's all well and good if you're operating in meters, but most charts that I know of operate in nautical miles. And so you either have to convert that to nautical miles by dividing it by 1.852, or you have to do it another way. Another way you can do it is by using another formula. It works out with a similar answer. It's not exactly the same, but the answer works out similar and is close enough. And that is that the distance in nautical miles is the height in meters multiplied by 1.854 divided by the angle in minutes. So that is 155 multiplied by 1.854, and then all of that is divided by 28 degrees times 60 minutes in a degree. So 60 minutes in a degree times 28 gives you that number there. So you throw all that into your calculator and you get an answer of approximately 0.171 nautical miles. So again, you can draw that 0.171 nautical miles on your chart from the lighthouse center. So that's a position line that you will find yourself on. So before I explain that once again, it should be noted that the 1.854 is not a mistake, and it is not supposed to represent 1.852 for nautical miles. It is actually 1.854, and it's a number that has been produced to allow this to work out correctly. So it is definitely 1.854. Now we can also take a compass bearing of this lighthouse, which will give us an additional position line so that we can determine our fix, our position. So in this case, we're using a compass bearing, which when converted to true bearings is 300 degrees. We plot that 300 degrees on here, and where it intersects, the vertical sextant angle is the fix. So that's this location here. So that's all I have for you today on vertical sextant angles. I hope that was of help and was of interest to you. If you have any questions or comments or any ideas for other videos, please leave them in the comments below. Also, if you like this video, please subscribe or give it a thumbs up, and I'll be sure to make some more videos hopefully of interest to you. Okay guys, thanks for watching, and we will catch you next time. Bye-bye.